Hey everybody, so today we're going to be going over the notes for section 1.4, which is angle measure. We'll get started right away. So an angle is formed by two non-collinear rays that have a common endpoint. Okay, so let's say we have a ray like this. We'll call that ray LG. And we have a ray down here, which is LV. Well, these two rays share a common endpoint, which is L right here, and they're non-collinear. So, and remember, non-collinear means they are not on the same line. So these are obviously not on the same line. And therefore, this forms an angle, which is right here, okay? Now the vertex is the common endpoint by which those two rays share. So the common endpoint of the two rays that form an angle. Okay, so let's look at this. So up here, for example, that would be the vertex of this angle, which this angle we would actually call angle GLV, okay? Or you could call it angle VLG, okay? So GLV forms that angle, or VLG forms that angle. Same difference, right? Okay, let's give another example of vertex over here. So let's go with, we'll make another angle here. So we're going to go with, let's see, BDR, okay? And we're going to say that D would be the vertex, so D is the vertex, excuse me, of angle BDR, okay? Okay, the sides of an angle. The sides of an angle are actually these rays here. Those form the angle. So we're going to say the rays that form an angle. Okay? So we give another example here. Let's make another ray. So let's go with, I don't know, let's go with VLM. Oop. And we're going to say that ray LV, so we're going to use the proper notation here, and ray LM form, no, it wasn't that form, I'm going to say are the sides of angle, and we're going to call that VLM, or we could call it MLV, doesn't really matter, okay? All right, now degrees is just a unit of measurement, okay? And that's what we use to measure angles. Okay, so a little symbol like, we've all seen that before. Acute angle, an acute angle is an angle that's less than 90 degrees, but greater than 0, obviously. So an angle, that is whose measure is less than 90 degrees. Okay, so here's an example. We'll say this is 60 degrees, boom, acute angle. Okay, a right angle, let me zoom in here, this is a little better. It's a little too far, I guess. A right angle is going to be an angle that measures exactly 90 degrees. And there's a symbol for that, you'll see in notation. So if you have an angle here that's 90 degrees, they'll typically use a box to show that as shorthand, okay? All right, so that's the first page. Let's see what we got here. Okay. So we have obtuse angle, straight angle, perpendicular angle, bisector. Okay, so an obtuse angle is an angle whose measure is greater than 90 and less than 180. Okay, that's an obtuse angle. So an example of that would be, let's say, 120 degrees? Sure. That's an obtuse angle. A straight angle. It's actually 180 degrees exactly. Okay. Formed by two opposite rays. So it's formed by two opposite rays. Okay. And an example of that would be something like this. Let's say we have two opposite rays here. So we have this R, L, Z. So we're going to say ray LR and ray LZ form a straight angle. Okay. So remember the notation here is important. Let me zoom in because you can see that. I wrote that kind of small. Sorry. So ray LR, which is this way because of the notation, and ray LZ, which is this way because of the notation, that forms a straight angle. So, okay. What else we got? Perpendicular lines. Okay, so perpendicular lines are lines that form right angles when they intersect. I guess I should say where, but when they intersect, whatever. Intersect. Okay, so if we have an example of that, it would look something like this. So we have two lines that are intersecting with one another. We have the notation to show that they're right angles. And that if this angle is 90 degrees, that means actually all these remaining ones also have to be 90 degrees. We'll get into that later. Okay, so we're going to say, let's call this line BE. This will be OM. So we're going to say line BE. I'm going to zoom in here so you see this a little better. So line BE with the proper notation is perpendicular to, which is an upside down T, if you can think of it that way as a symbol, perpendicular to line OM. Okay, so you'll see this symbol used a lot, and then you can see why the notation we learned in the beginning of this unit is so important. Okay, angle bisector, a ray that divides an angle into two congruent angles. Okay, so let's say we have an angle that looks something like this. We'll call that angle, let's see, AVM. We have a ray coming out of it like this. We're going to call that ray VL. And we're going to use this notation here. So we're going to say that ray LV is a bisector of angle AVM. So that means this is cutting this angle in half. It means it's creating two congruent angles here. So angle AVL would be congruent to angle LVM here. And you can see that I use a number of arcs. So they both have one arc. So because they have the same number of arcs, that notation would indicate that these two angles are congruent. Okay, the number of arcs indicates congruency notation. Okay? All right, so let's use some of this. Let's go through. I'm not going to do all these. I'll do one of each, and that way you can do the other one at home if you'd like, and I can check your work. So name the vertex and sides of a given angle. So this is obviously the vertex. So the vertex is I, and then the sides would be the two rays that form it. So this would be one side, that would be the other. So sides would be ray IH and ray IJ. Okay. Okay. Name these angles in four ways. Okay, so we can do it this way. 1, 2, 3. We can just list these letters out in order. So IHG. So angle IHG. We can do the same thing in reverse order now. So we can say GHI. So angle GHI. We can say angle 4, which is not a great way of doing it because honestly using numbers to classify angles is not great because oftentimes we use numbers to describe the number of degrees they are, so it can be very confusing to students, but in this case we're going to say angle 4. You can also in this case use the vertex to name the angle because there are no other angles at that vertex, but it's not a good habit to get into, and you'll see why once we get to the next example. Okay? So So as I just said, you wouldn't want to call this angle V, because there's actually three different options for that. If you call it angle V, it could be this angle, it could be this angle, or it could be the whole thing. So that's why I'm not a huge fan of identifying angles by just their vertex. Okay, so name all the angles that have V as a vertex. So there's a lot of angles here. We have this one, and the whole one. So there's three different angles, and there's different ways of naming each angle. So just because you might come up with something different does not mean it's wrong here. Okay, so let's do this angle here. So we're going to call that angle MVL. You could also call it angle 2. You could also call it angle LVM. This other angle down here, we're going to call that LVK. Because from L to V to K. And now the large angle, the big one, we're going to say angle MVK. And those are the three angles here. Okay. So that's about it. There's these three examples here you can try on your own. Okay, this is actually on the Google document, so you should have no issues accessing it. If you have any questions, let me know. All right, thanks, guys.